tough?
I'm gonna push through.
What if you're just too young?
That's not true.
What if you're not good enough?
That's not true.
Why? Because
I can do anything I put my mind to.
I believe in you.
Chin up,
Believe in yourself.
head high.
Tell me why.
We push through anything we put our minds to.
Good morning, grade 5 students. Welcome back to another new year. I must start off by saying Happy New Year, and I wish you all the best for this school term. Many did not live to see 2021, but we are blessed to live to see another new year. So we have something to give God thanks for, okay? So we are going to go into our subject, which is mathematics. And the topic today is population and sample size. And you see a diagram there that we are going to go into. All right, so we see the population and we see an example of the sample. All right, so let us go right into it. So we want to look at the difference between population and sample size. All right, so here we have 30 peas. And these 30 grains of peas is going to be our population, as the picture labeled there. Picture showing population 30 grains of peas. So this 30 grain of peas here, grains of peas, is our population. All right, this is our population. So therefore, our population is comprised of different kinds of peas. All right, so we have the red kidney beans, we have the split peas, we have the gungo peas, all right? And we know that our tradition is to cook rice and peas on a Sunday, all right? And we normally use the red kidney beans, don't it? Yes, we normally use the red kidney beans and we cook it down in coconut milk, season it up well with our scallion and thyme and so forth, right? And we have a nice rice and peas. So we also have the split peas, which we also can use in our rice and peas. Gungo peas, which we also use to cook rice and peas. All right, and don't even mention gungo soup. That's mouth-watering. All right. So these set of grains are the grains of peas then that we have here. Is our population. All right, so this is our population that we are working with. All right, so the different kinds of peas that make up the population. So these are the different kinds of peas that make up the population. So we have the red kidney beans, we have the split peas, and we have the dry gungo peas. All right, so these are the different kinds of peas that make up our population. Now remember that the population comprises of the red kidney beans, the gungo peas, the split peas. All right, this is our population. And these are the different kinds of peas that make up the population. All right. So you're going to take 10 grains of peas out of 30 grains of peas, which is the population. So you're going to take 10 out of 30 grains of peas. We are going to call it our sample size. All right, so in all, we have 10 grains of peas. So we have 4 red kidney beans, we have 3 split peas, which is what? 7. And we have 3 gungo peas, which is 10. So we have 4, 3, 3. If we do our calculation, we get 10 grains of peas. All right, so we call this our sample size. So we take this out of the population. All right. In other words, these 10 grains of peas are subset of the what? Of the population, which are the 30 grains of peas, because the 10 grains were taken from the 30 grains, which is the population we are working with. All right. So let me go again. The 10 grains of peas are subset of the population, because the 10 grains were taken from the 30 grains, which is the population we are working with. All right. Subset. So these 10 grains are part of the population. So we take these 10 grains of peas and we call it our sample size. All right. So we take 4 red kidney beans, 3 split peas, 3 gungo peas, and call it our sample size. All right. Now, when we're dealing with population and sample size, we actually deal with fractions and percentage. All right. So our sample size, remember that it consists of 10 grains of peas, as you see there. You see the red kidney bean, which is 4, 3 split peas, 3 gungo peas. All right. So we want to find the fraction for the red kidney beans, and the fraction is 4 out of 10. All right. 4 out of 10, because we take 4 grains of peas out of the sample size, which is 10 grains of peas. So we take 4 from 10. All right. 4 out of 10. 4 out of 10. All right. So our fraction would be 4 over 10. All right. So because we are dealing with fractions and percentage, my 10 grains of peas is out of 100. So percentage is out of 100. So the percentage now, to find the percentage of 4 over 10, we have to times it by 100. And when we times it by 100, we get our percentage, which is 40. So we say 2 rather into 4 goes 2 times. All right. And 2 into 10 goes 5 times. 5 into itself 1 time, 5 into 100 goes 20 times. And we multiply the 2 times 20. 2 times 20, we get our percentage, which is 40%. All right. Remember, the sample size is the statistics. So the sample size is the statistics that we are dealing with. All right. So for the split peas, remember, we take 3. All right. 3 split peas, and the fraction for that is 3 over 10, because remember, the sample size is 10 grains of peas. All right. So we take 3 out of the 10, which is 3 over 10, and we times it by 100. We do our cancelling, and we get our percentage, which is 30%. All right. Same thing for the gungo. All right. Take 3 out of the 10. So it's 3 over 10, and we times it by 100, which is the percentage. We want to find the percentage, so we have to times it by 100 and do our cancelling, and we get our percentage, which is 30%. All right. 30%. So let us move on. Now, we can make a circle graph to visualize what we have done. For example, here you have it. We have a circle graph, and we label our circle graph. We have grade 5 pea sample. All right, grade 5 pea sample. And always remember to label your graph. All right, your graph must be labeled. All right, and also must have a key. So we see that, remember, we got 40% for the red kidney beans, and we got 30 for split peas, 30% for gungo peas. So here we represent it on a circle graph, and we have our key, which red kidney beans is 40% and gungo peas is 30%, split peas is 30%. All right. So this is the statistics. So the sample size is the statistics. All right. Good. Now, we want to identify the population and sample from the scenario. So here we have a scenario here, and I want you to identify the population and the sample, which is very easy. So let us read. In an effort to satisfy students' needs, a school conducted a survey to determine the most preferred snack to sell in the tuck shop. The entire school comprises of 1,200 students. The sample surveyed comprised of 45 students. The school decided to sell the favorite snacks based on the popular responses in a survey conducted. All right, so what is the population there and what is the sample in that scenario? So you're gonna pause this video, think about it for 1 minute, and I will come back to you. So if you say that the population is the 1,200 students, you are indeed correct. And if you say the sample is the 45 students, you are also indeed correct. So you see the population there is the amount of students that make up the school, right? So that's the population. That's the amount of students that are at the school, that are enrolled at this institution, all right? Now the sample is the students that are taken from the population, right? So that's the sample size there, all right? So if you say 1,200 students for population, you are correct. If you say 45 students for the sample size or the sample, you are indeed correct, all right? So let's move on. So here is a bar graph now. All right, so we are going to look at a bar graph, and we see the bar graph labeled fruits students enjoy eating. All right, and we see that there are 50 students, and these are the fruits that the students enjoy eating. All right, so we have cherry, we have mango, we have June plum, we have guinep, we have star apple, we have orange, we have naseberry. All right, so these are the fruits that students enjoy eating. So we're going to look at some questions now that we should answer based off the bar graph here. Now, first point, about how many students eat the most favorite fruit. And we are going to look on the bar graph, and we're going to look on the students that look at the favorite fruit that the students eat. All right, and we're going to look at the most fruits eaten right there, and the most fruits eaten there is X. I'm not going to tell you, you're going to find it, because this will be placed on Google Classroom. So this favorite fruit is X. All right, so you're going to look there and you are going to identify it. All right, it says about how many students eat the most favorite fruit. You're going to find that. So how many students enjoy eating orange and mango? So you're going to look on the bar graph. You're going to look how many students enjoy eating orange and mango by looking at the statistics there and answer the question. All right, what is the difference in number between the most enjoyable fruit and the least enjoyable fruit? Now, difference in mathematics means to add, multiply, take away, or divide. Which one? It means to subtract. All right, so that's the operation of maths that we use, subtraction. All right, so difference means to subtract. All right, so we're going to look at now. It says, what is the difference in number between the most enjoyable fruit and the least enjoyable fruit? So we're going to look at that now. We're going to look at that now in the bar graph. Look at the least and the most enjoyable fruit, and we're going to subtract from that. All right, it says, place the fruit in order beginning with the least enjoyable to the most enjoyable. So we're going to look for that in the bar graph here. All right, you're going to rank them. Now, it says, how many students enjoy eating Naseberry? You're going to look and see how many students enjoy eating Naseberry. After which, you're going to round your answer to the nearest 10. Alright, that is easy. Now, it says, out of the number of students in the class, what fraction enjoys eating star apples? Now, you go back to your bar graph. You're going to look at the amount of students in the class. And then, you're going to find the fraction. What is the fraction now of that? So, out of the number of students in the class, what fraction enjoys eating star apple? So, out of the amount of students in the class, which is 50, what fraction of that, or what fraction of the students rather, enjoys eating star apple? Alright? Then, you're going to write your answer to its lowest term, meaning that you're going to do some cancelling now. Alright? You're going to do some cancelling now. You're going to cancel it down to its lowest terms. Alright? So basically that's it for today's maths. Wish you all the best again. Wish you a productive year. Keep safe. God bless. Stay tuned for the next teaching and learning exercise.